Welcome back. We're going to start with our Virginia forest LiDAR study. So this is the study area, West Virginia. That's how I zoom out a little bit so we can see Virginia. And this is Virginia as well. And I turn on some label for the counties. So that's why I have a Virginia counties. George Washington National Forest, which is this gray shaded area. And this one here is the legend for this one. And I have a shrub in green. Regeneration and small regeneration and green. And tree. And this is the LASD. So I will print the LASD. I will LASD in ArcGIS Pro. ArcGIS, okay. And we have the clip tool create this data set and LAS data set. Okay. Store. Let's see. File structure. Okay, here. What is LAS dataset? And this is the one that I had it yesterday. And if you still have some question about what is LASD, that stores reference or more LAS files on a disk, as well as additional surface feature. This is an industrial standard binary format for storing airborne LiDAR data. And for LiDAR data, and I explain here what is LiDAR data, and there are some features. Okay, point cloud. That's how we see those point cloud, and types of LiDAR, kind of terrestrial, mobile, different LiDAR data, and LiDAR support in ArcGIS, using LiDAR in GIS. So that's a lot of information that you can find in ArcGIS desktop, ArcMap, and you can choose different versions. And now if we have a 10.6, there are some different versions for you. That I designed this map, we have the study area, and I zoom out that we get the vegetation height. Those are all vegetation. And in addition, for this area, that we have the LASD and the DEM and SDM, digital elevation model and digital surface model, that we have each legend go with it. I'm going to move this a little bit to the middle, so this a little bit to the left there. And the one we had on our book, I'm gonna show real quick. All right. Use data. Let me pull out the document real quick, and then we will move on. And there. Okay, I'm going to scroll down. Alright. See, I created a new one. This I just got a picture because if I bring a new data frame, no matter what, adding the LSD layer, that I always sync with this 2 window. That finally I decided just export that layer as an image, and then I add on here. And scale bar, that for each I add in here, and those LiDAR image we do not need one, and I don't need the data credential. We could add it somewhere here. There was a little empty space, but I don't want to. This should be fine. Unless we really wanted to, and I can move this 3 item a little above and put it down here, or right on the lower right hand side corner. That's how I designed this map. I prefer instead of just portrait, I did landscape for the design. Okay, and my study area so that we can see more area, and I didn't use the topographic base map. This is topographic base map, and I could make a little transparent so I can see the elevation. The elevation here is a little higher, and then this area is a little lower. So as you can see from the colors for the elevation, the data set. Okay, we're going to move to the project 2, that Matrix State Forest, Pennsylvania. So the first step we're going to look is the scenario. We have to use the skill create the same way we will create a DEM and the DSM, digital elevation model, and digital surface model rasters from the LAS dataset, from which is this one, and use the raster calculator to subtract DEM from DSM to calculate canopy height, as the same here. You use the DN and minus DSM as we did previously. We use minus tool. Minus tool that we have. Minus tool. We used minus tool. Let's see, minus tool. Oh, by the way, I did have a Python script. The issue was that I cannot run Python. I still have to connect to ArcGIS Desktop Help because my ArcGIS Pro version is not supporting for ArcPy for some reason, or different version. Python Wing. I did have the code, but it couldn't find. Let me open it. So that's the 2 script. Okay, that's my script, and I couldn't run because, let's see, run. Click OK. The issue was the ArcPy, and I will contact them. They couldn't find no module named ArcPy. That's the issue for my ArcGIS Pro. I need to figure it out. But my version for Windows, ArcMap will work. But ArcGIS Pro, it has some issue that hopefully we get to taking care of. The minus tool, okay. Once we use the minus tool, we have to identify and investigate problem areas in the LiDAR and produce a classified map of canopy vegetation. The scenario, the same way, okay. Land managers can learn a great deal about the history of a forested site based on the amount, distribution, and height of the vegetative cover and the impact of wildfire and disease, the growth of young trees, and the presence of habitat features favored by certain wildlife species are all important types of information that can be derived from LiDAR. Most of this information is currently collected through time-intensive ground surveys, often in remote locations. Increased efficiencies in data collection will be welcomed by land management agencies and organizations. The Nature Conservancy's Pennsylvania's chapters want to use LiDAR to estimate the extent of various successional stages using vegetation height as a surrogate for age. This knowledge will allow the land managers to better understand what restoration and management techniques may be necessary to maintain a diversity of forest communities and species. LiDAR provides the opportunity to characterize different strata layers in ways previously not possible for satellite imagery. Canopy height can be determined by subtracting the bare Earth surface, DEM, and from the first return surface, DSM, surface return that will be DSM, Digital Surface Model. And LiDAR data is from PASDA, Pennsylvania Spatial Data Access. We can look real quick, okay. PASDA.psu.edu. Okay, so that you can have a lot of Pennsylvania Spatial Data Access, the Pennsylvania Geospatial Data Contiguous. That's very interesting for this design. Very nice. Okay, biota, energy, local government, NGO, and academic organization, hydrology, boundary, and recreation imagery data source. That's very nice. It's a good one to get data. I'm gonna save it in my folder. Alright, then we have the data already, and I'm gonna just extract it, and I'm gonna go to my download, and then the last one, PA, okay, I'm going to say 7-zip, okay, extract file, and click OK. Once I extract it, I will cut and copy, okay, cut. I'm gonna do is go back to my desktop and the folder, making spatial decision, right click on here and paste. Once I have it, replace file. I already have it. Let's see. What did I extract? Let's see, what did I extract? Downloads, okay. PA forest. I don't see PA forest. Oh, right here. Oh, it's already here. Okay. I'm sorry. I can just replace it. Cut, okay. I'm gonna, when did I do that? Paste. Okay, replace, okay. Alright, once I have it, that I'm gonna, let's see, I don't think it's gonna slow. New map, okay, new map. That for new map that I'm going to do is save it. This is map, okay, map. I'm going to change the name. Okay, the map name I will say PA, Pennsylvania. Okay, PA, and once I have a PA, and I don't have to do anything. The only thing that I'm worried is, let me just delete it. I'm gonna start brand new because, can I delete it? Alright, save everything. I'm gonna exit out. I don't want to work in the same excuse me. In the same map package with that this the projection, and it could cause a lot of problem. Okay, I'm gonna exit out. I'm going to get a new one. Everything start from scratch. Okay, everything start from scratch. Let me close this out. And I'm gonna go a blank one. The same way, find my folder and save it. There. And name, I will say PA Forest. Once I have a PA Forest, remember I have to connect to folders and change the environment settings and add a new map for sure, okay. Making spatial decision and close this out, add a new map, insert new map. Okay, then we have a map showing up here automatically. Perfect. Okay, this one will say PA. Okay, once we have a PA and we do not have extract folders anymore, and folder we add a connection and add the data folder where we extract the package, and the folder we have to go to PA. The folder connection will remain in here, and the duration of the exercise and folder connections are specific to the project in which we were created. And now I'm gonna find here PA data and layers, and right click on it and go to add to current map. And inside the data folder we will see there is a P folder, and that contains PA geodatabase layers with the data we will use here. And the user folder, I'm gonna go to command and use the data folder, and we will see PA map LiDAR LAS XML, which is the metadata for an LAS file. And we will right click on layer. We already add everything to the map. When we add the data, ArcGIS Pro creates layers for each data source, and the layer references the actual source data and can contain many different display properties. For example, we can change the colors of the layers and how they are symbolized, and the layer name and the labels. Now we can see the data display in the contents pane and the map view. I'm going to do counties. Right click on it, go to, I think I'll just right click on it and go to symbology and symbol and go to property. And I will change this to no color and outline. Outline just dark color. Click apply. There. That's Pennsylvania. Cool. And that's already forest. Now it's a good time for us to play around, and I think I'm good. And the only thing we have to be familiarize ourselves with the common GIS operations such as zoom, and this is pan and zoom to full extent and so on, and take a few minutes to explore both the data and the interface. We will see there is a contents pane. This is contents pane, this is a map view pane, and this is the catalog pane, and we can turn the layers on and off and to see what kind of layer it is, and we should identify this is point, and we have a polygon, we don't have a lines here. Okay, of course those are lines, but lines forms polygons. And the map derives its coordinate system from the first layer added to the map. So now we're going to look at the contents, and we will right click on map and go to see properties. Okay, coordinate system. And this is the NID 1983 state plane Pennsylvania South. This is state plane South. Okay, 3702 feet. Click OK. And what is the spatial coordinate system here? I'm gonna say it again. Let's look again. It's NID. I'm gonna write it down. NID 1983 state plane Pennsylvania. Okay. And next session, we will set the output coordinate system for geoprocessing to the same coordinate system as the data frame or first layer, because this projected coordinate system most accurately preserves measurements within the localized data. In the catalog pane, we will select project and expand database, which is right here. And this is my result. Everything will go in here, and this dataset will store all of the produced data file, and this data file just contain the package layers, and if you mess up anything, you still can add the layer. Nothing changes in here. You don't modify anything here, okay? We set the environments, geoprocessing environment settings, ensure that geoprocessing is performed in a controlled environment. And in this section, we will establish environment settings for the project. And setting environments ensure that the data will be stored in the appropriate place, which is right here. And the data comes from here, and nothing will change. You do not modify things here. Okay, and we establish environment settings for the project settings. This environment ensures that your data will be stored in an appropriate place with the designated coordinate system. And now here, analysis ribbon. I click this analysis ribbon in the top of ribbon and click environments. For environments, I will make sure that the Scratch space, current workplace, and Scratch workplace will be PA Forest and PA Forest geodatabase, and output coordinate system that I will use is the same as the Mexitrux, and that will be NAD 1983 State Plane, Pennsylvania South, FIPS 3702 US feet, and click extend tab. I will select Metrics, and click OK. I'm going to save my project. For this document, we will do is a process summary, list the steps we used to do for the analysis. And the summary is important because it will allow you to others to produce the work, which suggests using a simple text document for the process summary and keep adding to the summary as we do our work to avoid forgetting any steps. And the next list shows an example of the first few entries in a process summary. We will extract the project package and produce a map of Metric State Forest and create an LASD dataset and examine the LIDA dataset. Okay, and the analysis, once we have obtained the data and set the environments, we are ready to begin the analysis. And to complete the data displays, we need to address the problem. For this module, we have been asked to identify the different heights of the tree canopy. The first part we will do is that we will look at the LASD dataset. First, we will go to Tools and we say Create LAS dataset. Then I will navigate to find the data. Desktop. The data file is this one, okay? And click Open. An output dataset, that's fine. And the coordinate system, NAD 1983 State Plane, Pennsylvania South, FIPS 3702 feet, no LAS file, okay? And vertical units I will track, and we will do compute statistics, store relative path, click OK. Once we're done, we will track that vertical units. Of course, it will be US feet. Okay, right click on it, and we'll write it down this many times. Property, and then source. Okay, US feet, vertical units, and extent. And the LAS, we have a unassigned ground, model key reserved. Number 1 is unassigned, number 2 is ground, number 8 is model key reserved, and number 9 is water, number 12 is overlap and reserved. 15 is transmission tower. And point spacing, we have to use Python to look at the point spacing, Python. Okay, then I'm gonna type it here, import ArcPy. that argpy.describe. Okay. Control A, Control C. I'm gonna put a quotation mark and move out dot point spacing. There. The point spacing will be 4.247. 4.247. Yes. Okay. And 376. Okay. And we have to write a brief. And what is the mountain range? Mountain range will be LAS data is the Pinery Mountains. This is South Mountain. Right here, Pinery Mountain. Piney Mountains. Okay, 30512, 305 1.25 to 1397.77. And now our second step, once we have an LASD, I'm gonna actually zoom to layer. I'm going to copy this and I'm gonna paste it. This one I just called it LASD. There. Okay. Now I have a LASD and I'm open it. And now I'm going to create a DEM. Going to paste again. Say DEM. Okay, and I'm paste it again. And I will have DSM. And we'll paste it again for height. There. Okay, then we have to do DEM first. Okay, for DEM, we will do is that let's click DEM first. Okay, remember which layer we work on. We have to be very careful. And to review DEM, DEM is a bare earth model with a ground classification that shows points that are classified as ground compared to a digital surface model that shows the first return data from all classification codes. And we can access this by looking at the thingy. For DEM, that we going to click this and go to appearance. Now I'm gonna drag this to masked and change it into 2512345. Okay, I'm gonna zoom in to perfect. Really nice. Okay, then we can see, yeah, this is a lot higher. Okay, perfect. Okay. And then for points, I will click OK. So for points, I would say it's ground. And then I'm gonna go to analysis and tools. Okay, that will be LAS to dataset to raster convert tools. Okay. To convert the tools, we have to input the layer and output layer. That's fine. And you can check it's in my PA forest data elevation, and gonna change it into maximum linear binding. That's fine. Floating points. Okay, I'm gonna click run. Input, okay, and output. So this is our DEM, and elevation, okay, binding for the interpolation type is binding. This is interpolation type. You see interpolation type. If you do not know, then I can click for you. And the cell assignment is maximum and void fill method. Void fill method is natural neighbor. Okay, I have to change it again. Natural neighbor, and I'm gonna remove this. Remove, okay. Natural neighbor, floating points, and cell size. Okay, I'm gonna click run again. Factor is 1. Cell size, I have to change it as natural neighbor and maximum. Natural neighbor and maximum. Let me make a note. There. And once I have it, I go to symbology. Right click on it and go to symbology. There. And for symbology, drop down menu, show all. That I say elevation 1. I have This is gonna be weird. Okay, this is extend. Gonna remove again. Okay. Analysis. Let's run the tool again. Something wrong. OS data set to raster. This, okay. Let me just change it into DEM. Okay, then I have this is maximum, and this will be nearest natural neighbor. Click run. Okay, I think something wrong is here. I'm gonna browse, alright? Because each time I had this situation, and I'm gonna click OK. There. I think something wrong is here. Okay, click OK. Alright, then I'm gonna remove this and run again. Okay. Input, output, okay. This one will be maximum and natural neighbor. Alright, there. Okay. There. Okay, now we have the elevation. Okay. Alright. And I'm gonna go to symbology. And change it into elevation 1. Okay, perfect. There. Alright. Yay! Okay. Now I'm gonna change this DEM. Okay. Now we have DEM. This is our DEM, and I will have the height that we have the lowest elevation. Okay, the raster. It didn't ask any question yet. Okay. But this is the DN, and we will do now I'm gonna do is DSM. For DSM, okay. Now this is DEM, open for DSM. Now I have a DSM. Once I have a DSM, I'm going to do is link view center and scale. I'm not gonna link view first return, and select this and go to appearance, and that will be first return points. Okay, first return points. Okay, now I have a first return points. Let's look a little bit. I'm gonna change it to max 2, 5, 1, 2, 3, 4, 5. Same way. There. Okay, now I'm gonna go to analysis tools, LAS to raster, and the same way. Okay, elevation, and this will be maximum and natural neighbor and floating point. Size 10 and Z factor is 1. And click run and change the symbology. Perfect. I'm gonna delete height because I need the 2 layers. Delete. Okay. Then once I have it, I will say this is DSM. This is DSM. I'm going to go to property, symbology, and change it into elevation 1. There. Okay. Perfect. Now DSM, and we have to do height. DSM copy, and maps and paste. There. Okay, paste, and this will be height. Once I have height, I have to use the minus tool. Let me double click height. Now we are working on height, but I do need the DEM. Perfect. Okay. DEM. I don't think this is the DEM. Remove. Okay. Go to history. That's something that I didn't do it correctly, because the PA2, PA3, okay, PA2, PA3, PA2, PA2, PA3, I'm gonna delete this. Yep. This is DEM. This one is DSM. So now I need the I have a DSM, I need DEM. There. DEM, okay, right click on it and go to symbology. And I'm gonna put elevation 1. Okay, so now we have a DEM, DSM here, and I'm going to find the tools. It's minus spatial analysis. Okay, minus spatial analysis to determine the vegetation height, the bare earth surface DEM, and subtract from the digital surface model. Subtract from that, we will have DSM. It's like DSM, DEM, input DSM, DEM minus and height. There. Minus, okay, and then we will do integer. So in the catalog pane, I copied the DSM and changed the name into height, DSM1 to height, and on the analysis tab, I click tools. So for the tools and search for the minus tool, and once I have a minus tool, and here, that's our data set. Okay, we have the height. Actually, I don't need this anymore. And I have to reclassify later, but we cannot see attribute table because the data is render, okay, and it's not integer yet. So we have to convert into integer, spatial analysis, that we will have a -1, and here I will just say this will be our height. Click run. And the raster dataset that has a floating point or a decimal value does not have an attribute table. Okay, that's very important. I'm gonna highlight it. That's very important that you have to be aware. Very important. I'm gonna say it again. A raster dataset that has a floating point or decimal value do not have an attribute table, so we have to change. A floating point that typed to an integer, which will provide the raster with an attribute table. So the integer or integer tool will convert each cell value of a raster to an integer using this truncation. And now I can right click on it and open attribute table. That we can see the lowest elevation is being -7 and the highest is 1259. Well, it's still a little off, but better than nothing. And next step I will have to do is, oh my god, remember that the -1, I have to fix it. That's an issue. Even with my classification tool, it's not running. Module name import argpy from argpy environment, from argpy sa import. I think it has something to do. Error, no module name argpy. I need to fix. I still have to figure it out. I'm sorry. But we cannot run Python. What I'm gonna do is that for reclassification, and it's right here. Let's answer some of the questions first. I already have it. Reclassification. I have to do reclassification first. Okay. To determine the vegetation height, the bare surface, the bare Earth surface digital elevation model is subtracted from the digital surface model DSM, or the first return that we use DSM minus DEM, DSM minus DEN, DSM minus DEN, DSM minus DEN. DSM minus DEN, subtract from. Okay, and what are the lowest and highest value in the height raster? Okay, that the lowest elevation is, for me, it's 7 feet. Okay, -7 feet. This time I got -7. That's wrong, okay? And then the highest is 1260 feet. And how many cells have a value over 169? 169. 169. I have a 0. 129. Okay. 169. I have a 0. How many cells has the value less than 0? Then I have to calculate it. Okay. Less than 0. Less than. It's not equal. Okay. So I have 2911 plus 427 plus 85 plus 13 plus 3 plus 1 plus 1. Okay, this is 5. This is 90. 103. 103 plus 427. That will be 0, 3, and 5. 2911, 530, 1, 4. 4 3 3 4 4 1. Okay, 3 4 4 1 is less than 3 4 3 4 4 1 is less than 0. And describe the distribution of the cells that are less than 0. Let's look. There. Oh, it's spotted everywhere. In the middle. Yeah. It's right here. It's spotted. Which makes sense, okay? You have some canopy and it's spotted everywhere. Okay, spotted everywhere. Spotted in the middle, I would say, or everywhere. Actually, it's spotted everywhere. In the middle. In the middle. Okay. Kind of dispersed, okay? Not clustered. And we must symbolize the height raster and leaving out the negative cells and the cells over 196 feet and use the information here. So, reclassification. It's gonna be a while. Bear with me, okay? Save it first. Go to tools and classification, reclassify. Reclassify spatial analysis, input raster, it will be our height, value for sure, and unique, right? Unique, then we have to reclassify. 0 and below, it will be errors, okay, then vegetation height. I can just type errors. I would just say 0. Okay, from 1 to 5, it will be 1. From 6 to 15, it will be 2. 6 to 15. And 16 to 25 will be 3. And then the leftover will be 4. I know, this is tedious work. But it's done now, okay. Click run. Once I have it, that I can just put on everything, okay. Type of vegetation, I have errors. I would just say errors. This time I will say errors, okay. Let's see. Oh, shoot. What's going on? Oh my god. Gonna cry. Oh. Changing missing value to no data. No data, okay. True. Okay, so 1, 0 and below, it will be errors. 1 to 5, shrub. 6 to 15. 6 to 15 is 2. 2 is 2, it will be small regenerative growth. Okay, regenerative growth. Okay, regenerative growth, regenerative growth, regenerative growth, regenerative growth, regenerative growth. Okay, 16, that will be 3, 3, 3, 3, 3. Okay, 3, 3, 3, 3, 3, 3. And this will be 4, 4, 4, 4, 4, 4, 4, 4. Okay, for 4 is tree, okay? For 3 is a large regenerative growth. Click run again. Shoo. Something wrong is here. With a 0. Let's change the 0 into 5. Click run again. I never see this situation before. Oh no. Let's see what's the issue here. Reclassify. You know what? I'm gonna restart ArcMap, ArcGIS Pro. Then I will redo it again. Hopefully come up. Okay, let's see. I change the number and try it. Until 25, then I will have a 4. Oh, let's see. I didn't do it correctly. 1 to 5. Okay, 1 to 5 is 2. 1 to 5, 6. How about changing to 3, 3, 3, 3, 3, 3, 3, 3, 3, and then 4. There. Finally. I think something wrong with it, and I restart my computer. Oh, no, restart ArgaMap. That solved the issue. Save it. Alright. Sign. Okay. Gonna go to symbology. Symbology, that number 1. I'm gonna change it into no color. Okay, so label it. It will be errors. Okay. And for 2, it will be shrub. Shrub, it will be light yellow. Okay, number 3. Small region. Okay, region is regenerative growth. Okay. Okay. Oh, need a parenthesis. And then I will have large regenerative growth. The last one is tree. Dark green. Medium green. Light green. Perfect. Okay. Close it out. What are the dark colors? I think that will be no color. There is no dark color. Okay. And I have the white one with the errors. I can just delete those. That's fine. Oh, the tree color. Symbology. There. Look a lot nicer. Okay. Now I have a DEM. I don't need this. This is height. Okay. Now I have a height. I can make a layout. For this, actually I don't need those dots. Places, remove. Okay, this I don't need it. Remove. Counties, remove. Okay. I only need those. Remove. Okay. And height, I don't need those. Remove. And remove. And remove. Okay. I can just save this. Okay. And then can I copy a layout? No, I don't think so. Insert a new layout. Gonna do, I don't want to do portrait. Let's see. I think I will still do landscape. Okay, now I have a landscape the same way. Frame, okay, height. Height, I'm gonna put it here. And then map frame. No. Delete. This will be height. Height, okay, study area. Oh, this one is never show up. I'm not gonna add this, okay. Height. Zoom to layer. Back to layout. If I do 50%, I can see some of the elevation. No, I don't want to do transparent. Okay. That was how I exported it, and then I insert it as an image. Insert as a picture around here. And there. This is not a perfect picture. Delete. I'm gonna center a little bit. It is still a little to the left. Okay. I'm gonna move it to the right a little bit. There. Now it's a little to the right. You need to have a lot of patience to make a map, so I'm telling you. Okay, now it's perfect. Okay. It has the credentials. I could just make the credentials a little dynamic. So source, and then I'm gonna make a format. Okay, format it, make it a lot smaller, make it maybe 6. Okay, 6. There. Then it will be out of the way. There. Okay, now I need a DEM and back to the layout and map a frame, insert map frame. I need DSM and DEM. There. So DEM first and DSM. Then I'm gonna do format. Okay, format. Okay, width and height, I just do 3. And then 3, perfect, okay. And this I will do 3 and 3 too. Is it X or Y? X or Y? Y, 0, 8. Okay. 3, 3. 3. 3. 008. 0, 8. Okay. And I need one more map frame. Insert. Map frame, Pennsylvania. There. Appearance. Let's do 60%. Move it on top. Base map. I think I would change imagery with label. There. Zoom out a little bit. No. Okay. I have a West Virginia, and I'm not gonna move this town out. If not, I have this half and half. It's really crazy. Trim me. Okay, half over. Okay. Now back to layout. And activate this one. I can just do area imagery as well. There. Back to layout. And I can put title here. And everything the same way. I'm gonna move this here, yeah. Make it smaller. Format. I'm gonna do maybe 4, 3, and then halo. Property, halo. Okay, click apply. Perfect. This tiny bit thing. There. Oh. Perfect. Perfect, okay. Now I need a north arrow and drag it down a little bit. Okay. They line up and active. 36, 1, 2, 3. Okay. This one, I don't need anything. Five, 1, 2, 3. Activate. Remove. Okay, then I'm gonna zoom out. 5, 3. 5, 3, 1, 2, 3. Okay, perfect. Now I need legend and title and everything. Create a line. Oh my god. The same way I will mark the same color. You can see those guidelines are helping you. Very neat. Okay. I will move it once I'm done. Okay. Oh, there. Okay, now I'm gonna change the color. One by one. Okay. One line. And one line 2, I need to move it down. Height, I better move it on top. Okay. Line 2, okay. Gonna change it into red. 1 is fine. Number 3, Mars red. Okay, number 3, symbol. Okay, apply. Okay, property. Number 3, apply. Okay, one more. Number 3, symbol. Click apply. And for this, gonna property, symbol and appearance. Cancel. I need to select this. Property. Text. Okay, I'm gonna do red. There. Okay, this is study area. Everything will be the same, and I'm gonna just copy it and paste it. There. Very lazy. Okay. There. I don't know how to spell Pennsylvania. 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 Have to make it a lot smaller. I'm gonna do 12. Okay, feel. I already did halo. Shadow. I don't need a shadow. I will make a box for it. Okay. This is just vegetation height. And I need a scale bar right here. Okay. And legend. Let's do one at a time. Okay. Study area. DEM. How do I know? Because you see the vertex a little square over there. So map frame, this is DSM. Okay, picture, this is LASD. Okay. It doesn't matter because I can use the legend from here and move it down here. Okay. Let's add the scale bar. Okay, I think I will do it next time because I do have to go right now. Okay. I will show you how to add a scale bar. I know it's a little tricky. I'm gonna put either here and make it consistent and right here. So scale bar, create a box for it, and then for this one, this one, and this one, I need to add the legend. That's it. Okay. We have a study area, we have everything. I'm gonna save it and we will come back for it. Okay. Let's see, I can copy this, copy and paste. Set the same spot. I'm gonna move it a little bit. And I just need a legend. I will show you how to add legend and scale bar, how to change it next time, okay? See you next time.